Hello, and this is the part 2, which I'll just be doing a more complicated alkene reaction example. So I've decided to do this molecule of propane. So here I'll do the same as I did last time with HBr. The difference with this reaction is that this product, when it reacts with this molecule here, will form two products. And so these two products will have, in the reaction pathway, two different carbocations or intermediates in this reaction. And the formation of the product from these carbocations will either form the major product or the minor product. And according to a specific rule, it's quite easy for these reactions to know which is the major and minor product. Okay, so from the last video, we know that this double bond here is a nucleophile. It acts as a nucleophile, donating electrons to this here, which is the electrophile. And since the arrow points to the movement of electrons, double-headed as two electrons are moving, this is attacking this, as mentioned in the other video, that these two electrons here will move to this bromine, and will form a bromine with two electrons and a negative charge because it's gained an electron from this. This is the same as the other reaction, except now there's two carbocations that form instead of just one. And something that also I missed last time to talk about quickly is this here. If you look at the periodic table, the electronegativity of this molecule will show that this bromine is more electronegative than this hydrogen, and so it's given the delta minus, and this is given the delta plus because it is less electronegative, so it's a plus, and this is given the partial negative charge for being more electronegative. So this, having the overall negative charge, means it'll have less electrons to it, as this will be hogging it, and this is the reason this is an electrophile. Okay. So, two carbocations formed. This will do, I'll just try and make them separate. So let's pretend that this is two different reactions that take place. Okay. So, what can happen is, since this bond is attacking this hydrogen here, the hydrogen will form on this molecule, leaving one side that doesn't have the hydrogen with a positive charge because it will be lacking an electron that it shared with this molecule here. So, the two carbocations formed is exactly that. Either a hydrogen here, because the bond, it broke with the hydrogen and formed a bond here, or broke with the hydrogen and formed here. Okay, so I'll just draw these here. So this is the same with the three hydrogens on the end. And this one has formed the hydrogen on the top, because there's just two that can form, and this is one. I'll talk about which is the major soon, but I'm in no particular order right now. And of course, this is also a hydrogen because of this one up here being a hydrogen. So now that this has lost an electron, this carbon, it has got a positive charge here. And I'll just quickly draw the other product which can form. which is where the hydrogen is on this. So now this has three hydrogens, and the hydrogen from here, and a positive charge, because it's missing an electron. Okay, so now this carbocation still has this bromine to react with. If we look at them separately, so look at this one, and we know from the other video what exactly happens to this, where the bromine acts as a nucleophile because it's gained an electron before and now is electron rich, and this is missing an electron from the bond being broken to form the hydrogen, so it moves from the electrons move, both of them, to form this bond here, which is what we saw in the other video. And it's the same with this, except this goes to the, sorry, it's a bit wonky, to here. So if we look at the final products of each, we will see that from here, the bromine has gone to here, so the propane has become a 1-bromopropane. So I'll just draw a bromopropane with this bromine here. And this one's the same, with just the bromine being on the second carbon, so it's a 2-bromopropane. Oops, these are separate, so... Okay, so now that we have this, how do we know which one is the major or minor product? Okay, it's pretty simple if you know the exact rule. And it pretty much states that the carbon with the most hydrogens, or most H, get the most H, basically. And what that means is in this reaction, the most stable product, so this equals most stable, carbon with the most hydrogen get the most hydrogen equals the most stable. That basically means that the two products formed here, the one which has the hydrogen that goes to the carbon with the most hydrogens is the more stable and what is known as the major product. So one hydrogen and two hydrogen is, according to his rule, the most stable is where the hydrogen goes on to the one with the most hydrogens, is where the hydrogen is here, is the most stable product. Which means that the bromine goes to the carbon here as a secondary bromine. And so if we look down, the one which has that occur is this one here. So according to his rule, the most stable product is this one here. The most hydrogens on the carbon that had the most hydrogens, and the bromine is here, making the most stable possible product. And that's basically his rule, and it applies to a large variety of different reactions, and this being minor. I hope you enjoyed this video, and if you want me to make more with, for example, alcohols or aldehydes or ketones or or whatever, leave a comment and let me know, because this was just a basic look at alkanes. I can make more complicated alkanes. Just leave a comment and let me know if you enjoyed anything or if I should improve anything. Okay, cool. Thanks for watching.